Okay, round 7, take 7. All right, so when it comes to this lab 3, we are going to utilize a movie data frame that I have within my package. So we have to uncomment this and run it. But I'm not going to run it because I already did it on my end. And so you run it and then you press 3 for none if it shows up within the console that it wants you to update. So play a game, pay attention to the console. So I'm going to just comment that back out and then run this. I already ran it earlier, so I'm going to have that issue. Once you run this, and if you don't do this, this is not going to pop up. So just before you get nervous, just know that if you don't do it, you will not get. If you don't do this, you won't get this. So here's some variables. Here's some movies. I don't know when this was made. This is 1,000 movies from, I don't know when, 2006 to 2016. IMDb. So what I'm going to do is I'm going to delete this. I'm not going to put this in your code. I don't think I am. Let me see something. Okay, so this little doohickey here, or at least this movie data frame, we're going to do one-way ANOVA as well as simple linear regression. But one of the things I want to emphasize, or at least bring to your attention, is this genre category. It has horror, thriller, so on and so forth. There's some movies that have multiple classifications. And one thing I want to bring to your attention is drama comedy. Okay. So drama comedy, what we're going to do is create a new variable. This is not our class. We're going to create a new variable called, what is it called? Genre comedy drama. Sorry. So I'm saying the same word. All right. So what's going to happen is it's going to either classify a row as either drama, or it's both, or it's comedy, or it's none. Okay, so it's going to be 4 different types: comedy, drama, both, or none. And so this line of code allows me to do that. And the reason why we're doing this is because our question is the population mean of movie ratings the same across all specified? I'm specifying those classifications. Okay, boom. Is the population mean the same across all 4 different groups? So now if I go here, look where I click here, this now pops up, and now I have the specifications. So all these that say comedy only have comedy within them. If we go down to drama, these only have drama within them. They don't have comedy, or they don't have comedy within them. I have both. Should be both. Is it called both? You have other that don't include either of them. Either of them. What do I call the other one? Drama and comedy. So drama and comedy should show up after drama. Right? Here. Like this. Drama and comedy. Alright. Drama, comedy. Okay. That's fine. Look at the movies. Make yourself get happy by looking at the movies. I don't know. And so what we want to do is, first of all, do the summarization. So we've done this before, but here, look, I had to change my X variable. My X variable in this situation is going to be genre comedy drama. Got to enunciate my words. Okay. I guess we may just do one ANOVA in this video. And then what I want to do is look at ratings, and the variable for rating is just called rating, I believe. Rating. Good. So I'll do rating I want to find the mean rating for each of the different genres. Okay. Also want to find the standard deviation. Great, fantastic. Alright, so when I run this, that's weird. Run this again. Alright. You can see the means. But this is where I love statistics. Sometimes, it gets you kind of, because I don't know what's going to happen. But if you look at, first of all, the ratio of standard deviations, we passed the test for equal variance. That's great. But the means look quite the same. But if you honestly start to think about sample size, or like the sample sizes, this is where a lot of data can make it seem as if the means are not the same. And so you'll see what I mean in a little bit. All right. So we see this regarding the summarization. What we can now do is visualize our data. Okay. So we're going to say, I'm not going to change the X variable, Y variable because of time, but, within the labels, but I can change it within the plot just so I can see what it looks like. This should not have an issue. Okay, good. So, and look again, like I'm emphasizing to you all, it looks like the means are the same. It's a lot of variability in comedy. Some people are not that funny. Ha. Okay. All right. So, yeah. So you change X variable, change Y variable. That's fine. Change the table, it's fine. But it looks as if all of them are the same. Okay, again, sample size is playing a role in terms of a lot of plausible values that are near the mean that I don't necessarily, which makes these two means probably look different. Okay, I'm getting ahead of myself. The assumptions for one-way ANOVA is, one of the assumptions is that each group actually has a normal distribution. So we utilize a QQ plot for that. So this is a QQ plot, which is so cool that you all get to see this, right? You get to do, oh wow, when it works. I'm gonna pause this. Of course when it works, but I just forgot to add something. I need to add genre comedy. Put it right here, facet grid. Oh, look at y'all getting some programming experience. Woo! Alright, so let's run this. That's horrible. Is it? This is, I don't even know if this is real data for me to be complimented by the craziness. But just plot it, just try it yourself, and hopefully it works out. I'm not sure why is it looking like this, but this is generally how we would do this to be able to look at the relationship between our quartiles and our actual data. All right. This is nothing wrong with that. Okay, that's fine. We'll keep on going for now. Okay, I want to get to our actual ANOVA. Okay, so this is gonna be my X. This is my explanatory variable. I'll plug in my Y. Oh, I know why. Ha 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 ha. This should be ratings. This should be ratings. Sometimes, you just have mistakes. That makes more sense. I was about to just keep on going. So most of the points in the line, so we can approximately say that's normal. Normal. Yeah, this is an issue. But we'll keep going with our results, but like you can, this makes it not as trustworthy. Okay, so be aware of that. All right, shall we keep going? Yes, we shall. I'll put rating here. And then now I can actually run my ANOVA model. Look at that p-value. You're going to reject the null hypothesis. Crazy, right? When you look at this, you'll think that the means are the same. But no, that sample size is causing us to see a bunch of more values at which the means are not the same. Okay? And so in terms of data, if I eyeball this, I'll think that drama and drama comedy are approximately the same. And then these two are different from one another. And these two are different from one another. So in terms of combinations, there should be 6 different possible combinations with regards to the 2 keys HSD. Let's see what happens when I run this. Alright, so 6 combinations. Drama and comedy, there's a difference. Look at that p-value. Drama and comedy and versus comedy, there's a difference. Other than comedy, there's no difference. Drama and comedy and drama, there's no difference. And then other and drama, and then other drama and comedy, there's a difference. These two have differences. So you can try to write that out. This is very interesting. Okay. Very, very interesting. So with that being said, that's it for one-way ANOVA. Okay, you got to see it. Next video is simple linear regression. You can see I already have most of the work done. Alright, see you in the next video.